Hi, you guys. I did all these problems and then I was like, oh, they probably want to see like a walkthrough of them. But my COVID brain won't allow me to redo them all and walk through them. So I'll just talk through each one that I already did and make sure that you understand how they work. Now, first of all, when you read these and if you don't get what's going on, you're going to want to go back and watch the video that explains um, how to calculate different pH problems or how to solve different kinds of pH problems. And that video was posted last Friday. Um, and it included all the hard problems, which I didn't know, but you'll be fine. So I would say on this worksheet, the easiest problems are numbers 4 and 5 when it comes to just like kind of straight up what is the pH of something and straightforward problems. So we'll start there. But again, anything you don't know, you're going to want to go back and watch the video. There's lots of examples that I go through of each of the problems. Make sure you have all the problems copied down in your notebook so you can refer to them later. So I'm going to start with number 4. It says, what's the pH and OH minus concentration of a 0.0075 molar solution of HNO3? Well, it has the H in it, so that concentration is going to be the same as the concentration of H plus. So because it has the H in it. So take negative log of that, you get the pH, which is right here, and then if you want to find the concentration of OH minus, you can use the KW equation, which is this one. Oh, actually, no need to write that. We'll just write 1 times 10 to the negative fourth, negative 14th equals concentration of H plus times the concentration of OH minus. And so I've just rearranged it right here to solve for that. And you can see the answer is squared there as well. If you look at the next problem, number 5, what's the pH and H plus of a 0.0018 molar solution of BaOH2? Well, notice this one has the OH in it. So its concentration is going to be the concentration of OH minus this time. But there are two of them. Notice how it says OH2. So I'm going to multiply that number by 2, which I did right here. Multiply the number by 2. And then since that is the OH minus concentration, I can use the same equation I wrote here in blue, the KW equation, to solve for the H plus, which I did right here. And then once I have the H plus, if I just take the negative log of that, you can find the pH. So that's what happened right here. Okay, so those are like the straightforward ones where a lot is just already given to you. The other ones are a little not as straightforward, requires you to think a little bit more. And so let's jump back up there to 1, 2, and 3. So in number 1, it says 1.13 grams of hydrogen bromide or hydrobromic acid is dissolved in enough water to make 1.8 liters of solution. What's the pH? Well, pH, we know, is the negative log of H plus. H plus, it's just a concentration of H plus in a solution. So concentration is moles per liter. So what I want to do is convert this to moles right here. So there's my 1.13 grams of HBr, hydrobromic acid. That's my moles. Once I just use the molar mass, a thing you're very familiar with, and then divide by the liters, which was given to you in the problem. And so there is your concentration of H plus. How do I know it's H plus? Because there's an H in the formula. Once I have that H plus, then I'm able to do some other things like solve for the pH right here. Just use the pH equation, negative log of that H plus. And then POH, if you already know the pH, finding the POH is very easy. It's just 14 minus the pH to get you to the POH. So again, a little more work on that one, but that's how it works. In the second problem, same idea. This time we've got 4.35 grams of calcium hydroxide. So we're going to convert that now into moles. And we're going to multiply that by 2 because there's 2 OHs there, right? So I multiplied it by 2 way over here. Doesn't matter when I do it, but so moles per liter again, so 4.5 liters, so I'm dividing right here. And since it is the OH, again, then this is the concentration of OH. So my concentration of OH minus is 0.026 molar. And once you know that, you can rearrange and solve for some other things. Like here, I use the KW equation, and I solved for H plus. And then once I know H plus, you can just take the negative log of that H plus and find your pH. And similar thing happening here in number 3, except now it's an acid. You got 0.35 grams of sulfuric acid, H2SO4. Notice it's got the 2 there. which we're going to multiply in a second. So convert them to moles using the molar mass of sulfuric acid. Multiply that by 2 because there's a 2 in the formula. And so you're going to get your answer in moles of H+. How do I know it's H+? Again, because there's an H in the formula. So I know it's H+. And once I have that, then I can use the KW equation to solve. Oh, sorry, no, I'm not there yet. I've got to divide by my liters first. So 6.35 liters for that problem. This gets you the molarity of the H plus right here, 0.0012, the concentration of H plus, that's what the brackets are right there. And then take the negative log of that to find the pH. So problems do have a handful of steps, but they are all sort of similar. Again, your best resource is the video from last Friday. Until I get back, hey, then I'm your best resource, but you know, for the time being, I'm not. So, also for naming and formula writing, those are the answers to the last handful of problems. This has been really enjoyable. Everyone take care. Hope to see you soon. Okay, bye.